I'd like to start, ladies and gentlemen, today with this basics of Java values, expressions, and variables. This is quite essential stuff, okay? It's essential stuff for building up a model in this. It's going to be very, hopefully, helpful in learning to read things. Okay, so one of the most important concepts when working in AnyLogic with Java is this notion of a value and the things to compute values, which are called expressions. They're like formulas, okay? A value is a single quantity. It can't be further evaluated. And there's many types of values of different types. So integers, floating point values, characters, booleans, strings, for example. Now, what's notable is this last sort of value, it's a reference to an object, a thing like a string, or it's a reference to a person, or it's a reference to main, or it's a reference to a home. These are references. They're values. And we can do things with them just like we can to other values using expressions. So what we call an expression in Java is like a formula. Conceptually, it's a formula, ladies and gentlemen. It's a formula that computes a value. When we evaluate it, when we compute it, when we apply this formula, we calculate it, this expression, it calculates a value. Okay? And for years, you've been writing these sort of expressions in algebra, using them in Excel and calculators and things like that. This is not that unfamiliar. Probably everyone in this room at one point or another has put into Excel, this cell is equal to the sum of these other two cells, for example. You're calculating a value based on an expression there, okay? Expression is just how we in computer science call these things. So an example would be 2 times 5, or 2 divided by 5, or 1.0 divided by 3, or a plus b times c, or what have you. A greater than b, that's an expression as well. This is also an expression. This.getConnectedAgent.name. That gets my ICE connected agent and gets its name. If we count up from 0, we call it the I plus 1 if we count it as going from 1. These expressions in general calculating values, sometimes they could change things. Like you could say A equals 2. That's actually an expression. It returns a value, 2, but it also changes something, okay? Calling a function can't return a value, but it can also change things along the way. Okay, so, whoa, that was exciting. So here's some common expressions in Java. There's literal expressions, things like this. These are all expressions. This is an expression. It expresses an array of values, one followed by the other. It's like a vector. This is an expression. It expresses a string. We can have comparisons here. What type of thing does this evaluate? If we say A greater than B, what's the result of evaluating it? It's either true or false. That's right. And mathematical operators, you've seen that. A plus B, A minus B, A divided by B. Also, we can have something A dot B. Here, A is a reference. It's pointing to some particular thing, like a person. And we say, or a home. Remember we did this? Remember we saw in that model just a short time ago? Does anyone remember that? We said, oh man, I closed my AnyLogic. Where am I? Okay, let me call this up. Remember we said the home count occupying occupants or something like that? That was an expression. The A is a reference to a person, and B is the thing in the person, like the count occupants. So let's go call that up. This was our model. It's not located in here, but we'll locate it in. It's called institutional mobility here. Okay, and this thing is. Remember we set, for example. Remember this little state chart, and when we came into this, for example, we did school.countOccupants. That's exactly that sort of expression we're talking about. It's exactly this. School, we're asking a particular school, and we're asking what are its count of occupants, and then we're changing it, okay? We're doing plus, and we're saying increase it. Ternary operator, we've seen this many times. We say random true, 50%, it's red, otherwise it's green, or what have you. Or it's male, otherwise it's female, right? Okay, and a function call is an expression as well. Okay, there's Boolean expressions. We've seen this. We just saw it recently. Where did we see that? Does anyone remember?
When we were setting up the criteria for kids.
Exactly. It's in the same very model. And it was exactly this. Remember that? We said if the child is greater than 5 and their years is less than or equal to 18, then we do this thing. So this is true if this is true and that if true. False otherwise. Okay? So if either one is false, it will be false. And indexing is another thing. We say A of 20. A is an array. It looks up the 21st element of it because 0 is also an element. 0 would be the first element. 1 would be the second element, etc. We could have a method call here. This is very common. We call this method. We give it the 2 pieces of information it needs for its so-called 2 parameters, and it will return. And then we've used this a lot with 2 strings. This concatenates the strings. It puts them next to each other. It appends them. So remember, I have this plus, I gave birth to baby plus such and such. That's exactly what that was. It concatenates these things. Okay, now this is where the rubber meets the road. In learning, so it's easy to get confused at first when you look at a long expression. How do I read it? How do I make sense of this thing? So I see something like that. Where do I start? It's all this jumble of things. Well, okay, you start on the left. Start at the beginning, you go to the end and stop. That's what Lewis Carroll said. But the rub is knowing where the beginning is and where the end is. Beginning here, look at the left. Okay, so this A, we see a dot. It has to refer to a particular agent. Maybe it refers to the person. We asked, okay, let's get their connected agent, their ith connected agent. Oh, that returns their third agent, say. That now refers to somebody. So having evaluated this, it's referring to somebody. The fact that we called this, it returns a reference to someone, and we're going to ask, maybe that person's their mother, and we ask the mother's name, and that returns a reference to a string, and then we ask that string's length. And we say, what's the length of this string? And her name is Alice, and so its length is 5. So this whole thing evaluates to 5. We start with this agent, this particular agent, ask about its mother, perhaps, ask about its connected agent, maybe I is 0, so it's the very first connection they have, and we ask for its name and then the length, okay? And they're routinely strung together like that. Now, in general, we try to keep it a bit shorter, but you will see expressions like this sometimes to sort of capture things. It's good practice to break this up into pieces. So you might say, for example, person mother equals a dot get connected agent of I, and then you say mother dot get name dot length to refer to that mother's, and it makes it clear. Oh, you're getting their mother. That's what you're getting. Okay. Okay. Now, right. So in Java, we can hold values in what are called variables. And a variable is really useful because it lets us give a brief name to something. So we can say, for example, this is AnyLogic 6, and here we're giving a brief name M to the main class. Back then, you didn't have a thing called main you could use. So you might give, instead of calling get main every time, you could say, let M equals get main. It's just a name for that value, that reference. And it lets you refer to M in many places here. Here's M used in many places, okay? And you might give a brief name to your X position, your Y position, and then you'd use it in a number of places. You give a brief name to the result of this calculation called C, and then you use it in many places. Okay, so here we can give names to values by declaring a variable, a new variable. Now, we actually saw this before. Does anyone remember where we saw this when we declared a variable in one of our models? We actually saw it this morning with the baby. We had the name baby. Remember that? It was called, I think it's this open population model, North Carolina. Here it is. It does credit to your state. So let's go to person, and we're going to go see where this delivery took place. Remember, we gave this name to the baby. So here, this add population returns a reference to the baby, to the new person, and we give it this nice, convenient name, baby. And then we use the name baby to, for example, to set its values, etc. Okay, so we give names to values with variables, and that's really useful. That's really useful because a lot of these functions return values of that sort. Okay, so variable declarations can be used to associate a name with a value. And when you do this, you have to specify a type associated with this. So for example, in this case, we had to say this baby, this value baby is actually a person. It's a reference to a person. That's what that means. It refers to some person. Maybe it's null, meaning it doesn't refer to any particular person, but maybe it refers to otherwise a specific person. And so this is a person. In other cases, we'll say, oh, it's a double precision value, or it's a reference to main. So that's why we have to stick that special word up in front of the variable name. Okay, and in general, there's many types. We've seen them. We've seen, I think, all of these doubles, things that are doubles, right? My x position, my y position, things that are ints, the count of people in a certain location, things that are booleans. So am I male or am I female, or am I male? Yes or no. So true or false. A string. It's a quoted thing. Okay. So when we declare a variable, that's what that's called. We say, okay, there's this variable called baby. We have to give its type. Okay. And the value of a variable can change over time if you assign to it, but by default it stays the same. So this baby, we could later say, baby equals null or something like that, and then we'd change what value baby holds, but otherwise it's just whatever came back from this. Okay? Okay. So here's a bunch of sort of variable uses, and then we end up using them. Okay. I don't think we need to talk about that particularly. So time is limited, so I'm watching this. Right. Yeah, this is not too important for your immediate needs. Well, in general, you should be aware there are different types of variables. One type of variable is what we've declared here. This is called a local variable. Another type of variable is something that we create. If we create a function, we might want to pass it a value. So it has what are called formal parameters. It has arguments that we pass in, and we give them names. So that might take in an X and a Y position, like move to. And those are a different type of, those are also variables, and they behave in a very similar way. Okay? Right. So let's talk about various assignment variants. So we can assign to a variable like this. We could say age equals 0. This dot color equals color dot red. Right? We've seen that many times in our models. Color equals red. Right? Nothing to be scared of. Color is a variable in our model. an explicit variable. And in general, if you have variables being used in your model, I'd encourage you to make them visual so you can go and inspect them when you're running the model. You can go and look at what values they have by clicking on them or by seeing it printed. So we could say color equals red, ethnicity equals some random ethnicity, or we could say, random from ethnicities.value, right? Or we could assign to a population size if we wanted to. So we can make assignments. And in general, the types of assignments you can do are many. So we've seen this and we've seen this. What do those mean? Can anyone tell me? What is this one on the left, this one right? What does this one mean? Increment, yeah. So it actually takes the value, whatever's in A, and it makes it one bigger than it is, and it uses the current value. So this actually has, this expression computes a value too. It actually secretly, it side effects this thing, it modifies it, but it uses the current value. So if you use this in an expression, this will be the value used, is the current value of A, but then it will update it. It's like taking that thing from the ticker tape and the whatever they call them, the little things you pull in the place that does your medical testing or whatever, or the DMV. You take the number. That's exactly what this is. You get the current number and it increments it as a side effect. This gives you the current number and it takes one away from it as a side effect. And then you have things like A plus equals B, which is basically shorthand for saying A equals A plus B. A times equals B. A equals A times B. A divided by equals B. A equals A divided by B. Similarly with minus. Okay? So these are just shorthand ways. And they're not totally just arbitrarily messy. Like they're not, there's a reason that we do them. It's because if you imagine you have a long variable name, and you have, the variable name equals the variable name times B. Sometimes it's not immediately obvious. It's the same one in the left and the right. So you have foo bar equals foo bar times B. You have to kind of look, is it foo bar on both sides? But if you have foo bar times equals B, then it's clear it's the same variable that's being multiplied by B, being scaled by B. Okay? These provide useful shorthands, it makes it clear what's going on. Okay, so have some explanations there, and each of these has a value. It's not really great practice to use these as part of expressions, as part of a bigger expression, but you can do it. You could say, A times equals 2. A times equals 2, and you can add 1 to that. And if A here originally equaled 3, then this would evaluate to 6. A's value will be updated to 6, and then you add 1 to it, it will be 7. It's not really good practice to do that, to use it as part of a bigger value, a bigger expression, because if you then copy this several times, cut and pasted it, you'd accidentally be doing this change several times. So you will see these things, just like you'll see A++, but my own advice as far as AnyLogic is only use this, don't use it as part of a much bigger expression, just use it pretty much by itself. Okay, so let's see. So we can do things like this. A of 20 equals a plus. So this is saying increment by 1 the 21st element of this array. Again, it's 20, it's element number 20, but it starts at 0, so hence the 21st element. Incremented by 1. This is saying whatever, so I'm pointing to a person, get their connected neighbor, okay, and actually it should be get connected agent, I think. Number 2, take their income and multiply it times 2. So we could do this. This should be connected agent, not connected neighbor. No, I can't modify it here. I'll modify it elsewhere. Okay. And similarly, we can do things like this. A's mother is equal to this certain person, or A's mother is this certain person who's the third person in the population. This whole thing, this is referring to me. I get my reference to my main. I get the population in there. I find the third person in it, and that's going to be the mother of A. Okay, so it changes who their mother refers to. So let's talk about this. Suppose we have this A dot mother equals this get main population of 2. I'd like to explain what's going on at a mechanical level. Okay, so precisely what's going on. So here we have A, and they have a mother who's currently null. Before we execute this, their mother is not known. It's set to be nobody right now. Okay. Now we're going to first do this and then do this. Okay. So first we have A being this, and here's M, and then whatever this is, it refers. Okay, it's probably to some agent. This is their associated main, and then main has a population in it, which looks like this. Each person in the population is shown here. So this is person 0, person 1, person 2, person 3 is this one. These are also agents. Okay, say persons. Okay, so before we do anything, before either of these are executed, we have this. Then we say A dot mother equals M. Now this mother refers to this person. You see that? It refers to that because M referred to this, and now we say A dot mother equals M. Whatever value is in M, namely the value referring to this, becomes the value here. So now the mother is shown as referring to the same person, the same underlying person, this person whose age is 40. Okay. Does that make sense to you? Does that make sense? Okay. Questions? Yeah. So sorry. This person A will now have a mother who is the person referred to by M. Is that helpful? Okay, yeah, so their mother will be whoever's referred to as M now, by M. Okay, now watch this. Now if I say A dot mother equals get dot main dot this dot get main dot population 2, what's going to happen is we're going to switch. Their mother used to point to this, now it's pointing to this one here. Why? Because this referred to main, and so I do this dot get main. If I say this, it's referring to some current person. If I say this dot get main, so actually this should be another sort of this, and then the main associated with it is pointing to this. This dot get main will return a pointer to this, and then I say, okay, give me the population that points to this population. Give me the second person, 0, 1, 2. It's this one here. Does that make sense? Yeah? Yeah? Okay, this, there's actually, I should have corrected this, and I will do so right now. The actual thing that's going on here is it should have been clearer in this regard. This is actually referring here to someone who's associated main. So really, we've got this. Okay. And, yeah. So we have A, yeah, and this is referring to whoever's. So if this code is inside of a person, it's referring to the current person. Okay. It's referring to the current person, and they're associated with a main class. So they have a main here, which is referring to this thing here with this population. So they have some main class with which they're associated. So let me see. they're referring probably to a person whose main class, whose associated main class is this one here. So that's a more accurate depiction of what's going on here, and I'm going to see if I can copy it to these later diagrams. So rather than this pointing directly, hey, oh man, I may have to do that later because this is being truculent. Oh man, come on, boom. Okay. Hey, wrong key. Okay. There we go. And similarly for this guy. This is a better depiction of what's going on. Right. So okay. So this here we have this pointing. Gosh, the arrow got hidden. I'm not sure why, but yeah. This arrow didn't get copied. Sorry. This is needed here. Good. Okay. Happy. There we go. So, what am I saying? Yes, this should be main. Sorry. This should say main, not this main. It's associated main. This may refer to a person, and its associated main class is this other red one. Okay. Yeah. To be. Thank you. Thanks. It's just kind of the name of it. So thank you very much. Yeah, that's a great idea. So it's white like this. It's their sort of the name for that field in it. The name for that reference. Okay. That's good. Thank you. Great. Okay. Thanks for your patience with that. While I update it. So that's the start referring to something which has a get main associated with it. So presumably there's some reference inside of it to main. And so at the beginning, A has a null mother, and then when we assign A dot mother equals M, right here, what happens is that mother is updated to refer to whatever the value of this refers to. And then when we say A dot mother equals get main this dot, and this will be calling get main, so it refers a reference to it returns a reference to this main object, and this main object's population is obtained, so it returns a reference to this thing, and then the third element in it, 0, 1, 2 is found, returns a reference to this, and this guy points to that. Does that make sense? Yeah? Okay. Okay, so those are my comments on expressions. Expressions are probably the single most important thing to master in AnyLogic. They appear just in dozens and dozens of places here. In this model alone, we'll see this is an expression, right? This is basically an expression associated with fetching one of these fields. So it's like we have main pointing to this main, and we're getting from main the mortality rate. So that's like one of the items inside main, right? Obviously here's another expression, main.fertility rate. This is another expression testing if the value of the sex. Here it's called a parameter. It's a Java variable. Whether it's equal to this is a particular value as defined by this optionless sex. Here are lots of expressions. This is an expression. It is picking a random person from sex of values. This is an expression. It's getting the ethnicity referred to me. It would be somewhere in here if I had a thing called ethnicity. This is an expression. It's giving a reference to myself. So this refers to my current person. So if a given person is executing, they're undergoing delivery. This refers to them, themselves. Similarly, this is an expression. It calls off to normal with the value 10 and with whatever my x coordinate is. This is an expression concatenating all those things, lining them up and appending them, and then the result of that we call trace on to actually print out. Okay? So you could see expressions are littered throughout AnyLogic, and you really can't avoid them when you're dealing with AnyLogic. Another place we've seen them most clearly is when we have these for the population, we've had to calculate statistics, right? So if we have here in our population and we have to add a statistic, here we're basically specifying an expression. You notice it says expression there? That's because it needs that sort of formula. So here we might do, count pregnant or something like that. And here we're going to count the number of people who match this condition. This condition is an expression as well. Here we're not taking the average of an expression given people who match the condition, but this condition item dot. So here sort of have item referring to something, and then we do, pregnancy chart. So what is it called? State. Is it called state chart pregnant, or I thought it was pregnancy, or maybe I called it natality state chart. Oh, what did I call it? Oh man, I called it fertility state chart. That's what. Yeah, fertility state chart. It's just like I'm saying, okay, item points to something. From that pointed to thing, get that state chart. Now from the state chart, now I'd like you to calculate the result of the saying, is state active? So I'm asking the state chart, is this certain state active? And I refer to person dot non-pregnant or dot pregnant. Now, I guess this is one slightly more advanced thing it's worth knowing about. This person thing that I'm saying there, what's this thing? Well, this is actually just a number, okay? This is just a number. It's a number that denotes that someone is pregnant. It's a number that denotes this particular state. Behind the scenes, that's what that is. It's a number. And that number is used to identify that state when asking, hey, is a certain state active? Now, that number does not belong to any one person. It's not that the number denoting pregnancy is not the purview, it's not the property of, it's not an attribute of a particular person. It's a general thing that all persons share. They have a certain way of saying, I'm in the pregnant state by giving it a number. That state has a certain number. And so it's shared by all persons. And so it's a special type of variable. It's not a variable that lives in a person. It's not a variable that's just a local variable like baby, like this thing, like baby. It's a number that is shared across all instances of person. It's a number shared. It's a number associated with a person class. And so the person class can actually maintain certain variables. And those variables are called confusingly, terribly confusingly, horribly confusingly, static variables. Okay? And you'll occasionally see them. You can declare a variable to be static within some context if it's a value that doesn't change between particular people. If it's something about personhood, you want a general sort of one value across all persons, you can declare something a static variable. And you'll see it. If I drag this in here, do you remember that thing I did next ID? Do you remember that? To assign those things? I had two choices, and I decided one way to do it, put it in main, and that was fine. Another way I could have done it is declared it a variable here within within person, and I could have declared it a static variable. in which case it would have belonged to persons as a whole. It wouldn't belong to any one person. All persons would share one variable. And then we would have called it person dot next ID. And similarly, all persons share this designation of the pregnant state. Different persons are in the pregnant state. They differ in whether they're in it or not, but they all share the same way of denoting it, calling it person dot pregnant. Now, how would I know that? Well, among other things, let's go take a sneak peek at that. Let's open up the Java editor and let's search for pregnant. Okay? Let's see where pregnant occurs within this context. There it is. Look at that. As I told you, it's just the number. It's static. It's shared among all particular people. People don't have a different way of denoting the pregnant state. They just share one way of calling it. It's number one. That's the state. It's the number one. That's what it means behind the scenes. So that's why it's called static. It's final. It doesn't change after it's assigned. We don't have to worry that someone's going to assign to it again. And, well, it's a short designation. It's not a big number. It's a short number, and so they put that in there. It's not too important, but it can be useful for storing it efficiently. So this is what's going on behind the scenes. It's a static. Yes?
When we're writing regular code in AnyLogic,
yes.
There's no option for the variable to be short. Do we have to go to other and write short?
Yeah, you can write short as other. Yeah. If you want to, you can do that. There's, if I find it rare that you'd have to, but sometimes you can. Similarly, if you want to, is there a float even as a default? I'm not sure there's a floating point number. It's all double precision floating point. But maybe there's there's no float, but you can do other and make it that. Okay? So other questions though? No pun intended. Other questions? So anyone want to share challenges when dealing with these sort of things? In understanding these sort of models, are there any specific things that really throw you off? For example, if you look at this, things that are just really confusing, like what does this really mean?
Still wanted to practice the this versus item versus self.
Oh yeah.
Repeat what you said earlier about that.
Oh, okay.
You might get it.
Okay. So we're looking at code which is associated with person, okay? Divides part of personness. Now, whenever this code is running, it's going to be running associated with a given person, right? So a given person is to be coming into this state, coming into the home state. A specific person is going to be coming home, coming into that state chart, right? It's going to be a specific person. And so it's always going to be running in the context of a specific individual. And that individual, the reference to them is called this, to myself. That's me. It's me who's coming home. It is me who is, and this may sound a provocative statement. It's me who's giving birth, right? It's me. This is the way Java writes me is by this. It's the current person, who's the one running and doing this stuff. It's the one who has the state chart and has a particular value of sex, ethnicity, and mother. Okay. Now, sometimes we have to write it. Like when this delivery takes place, we have to say, okay, who's the baby's mother? And it's me. It's me. It's the one who's giving birth. It's this. It's the person who's giving birth, the one who has this state chart. The state chart is running associated with a particular person, and it's denoted by this. So that's the mother, she's the one giving birth. She's the one undergoing delivery. She's the one that's been pregnant and now is undergoing delivery. Now, this baby, when it comes into existence, it's going to be running its state chart and stuff like that. And this inside of that baby will be pointing to the baby. But this is kind of this is referring to me, okay? Now, that's used in many places. Sometimes it's optional, like saying this dot ethnicity. That's just emphasizing it's sort of my own ethnicity here, not the ethnicity of the baby. It's who doesn't yet, not even yet coming to existence. It's my ethnicity, but that's optional. And a lot of the times where we don't fill that in, like main, I could have said this dot main. It's the main variable associated with me, but I didn't do that. I could have this dot get x. I could have just said get x, and it would be my get x. So in general, this is referring, and this has delivered baby. I have delivered the baby. I'm the mother, right? So this is very common and it's standard Java. Item and self, that's just AnyLogic stuff in particular cases, and they need a way like for specifically for this sort of thing, you could refer to location self to find out the attributes, and that's just them allowing you a way to sort of say who's the agent, to be able to refer to the characteristics of the agent when setting their X and Y locations. Now, this is actually running in main, so this is referring to main. And so they need another way of saying self. They need another way of sort of referring to the agent to be, being created, because this actual code is being, before that person comes into existence, we're going to determine their or while we're setting them up, we're determining their X and Y values. This code is not actually associated with them. It's associated with main. And so we'll refer to them as self, but yeah, this is something different here. Now down here, this item thing, this code is also running in main. It's going through each person in the population in turn, and this is the actual code for it. It's going through each person in the population and calling them item and setting and testing whether they match the condition. If so, it counts them. But this code is actually in main. And so this is actually referring to main. It's referring to main because main is the one who maintains the population. Oh, it's not asking each person, do you match the condition directly? It's sort of in main. So they have this thing called item that refers to kind of the person under consideration for counting. But this is all being considered by main. Main is the one computing the statistics. Is that at all helpful?
Yeah, it's like I can also the difference between this and then self and item.
Yeah.
And now self and item feels weird. Like why one versus the other?
Oh, it's arbitrary. They just decided, hey, we need some way. I mean, we're going to be asking, should this person be counted or not? You need some way to sort of ask about the characteristics of that person. So we need some way of denoting, of designating the person under consideration. We need some way of asking what is their sex, or are they pregnant or not, or what is their age. So we need to refer to them somehow, and they use this word item for it, which is not a terrible word. I mean, it's not a particularly good one. It's just not terrible. And the self thing, well, they just thought that would be kind of nice. Maybe they should have called it agent to be created, or agent being created,
Or item being created.
Item being created, or something like that.
Yeah.
But they called it self, which is a little bit confusing. Is that helpful?
Yep.
Okay, great. Okay, I know Maria has challenges associated with getting to daycare, and I don't want to hold her up. She's going to be, I think, taking us. So any other final questions before we wrap up for today? We're going to be going on to additional material tomorrow, particularly associated with statements, which directly build on this material, because statements use expressions. An if statement has an expression to see, is it true or not? And if it's true, it does one thing, otherwise not. A while statement has an expression in it, etc. So they're using expressions, and we'll get to see that more tomorrow. Okay? Any questions? No? Okay. Thank you very much.